The NGLMS Clerical Review Tool is an independent part of the next generation linkage management system software suite, and this talk describes its operation and how it might be used in other contexts. A new graph-based paradigm for linkage management grew out of questions we asked ourselves doing probabilistic linkage. Why are we repeating so much work? We calculate similarities between records, find and tag related records, then throw away the details, the very thing we're interested in. What if we kept the relationship data? This opens up a rich world of investigation. We can vary thresholds to evaluate linkage sensitivity, clusters can be extracted on the fly, and we're no longer constrained to a one-size-fits-all model. Different algorithms can be evaluated without having to recalculate expensive comparisons, and different sizes and types of clusters can use different algorithms even within a single project. The paradigm applies equally well to probabilistic and deterministic linkage, as well as different data models, being independent of whether a data spine or ad hoc dataset to dataset matching is used. It also works well with hybrid storage models, where some data might exist in relational databases and a parallel graph architecture used to add graph-based functionality. Such complexity required a flexible review tool. However, the resulting review tool is not tied to the graph approach and can be used with non-graph-based data. The NGLMS was designed as a loosely coupled software suite with relatively independent components to be employed at need. The loose architecture is what frees the review tool from the constraint of only working with the NGLMS. The current third iteration of the NGLMS consists of a data layer, originally designed to be just a graph database, but now expanded to include graph relational hybrids and even legacy purely relational databases. On top of the data layer is a code layer, implementing data management and enforcing data integrity. Initially, this was a REST API, on top of which all the command line tools were implemented. All command line tools are now implemented on top of a data access library, and no direct database access occurs, with a careful exception for bulk data loading. The REST API is now implemented on top of the data access layer. Scripts written incorporating the code library are written in Python, but any language can be used to write scripts exploiting the REST API. This provides great flexibility for the construction of tools. One such tool is a small HTTP server which presents the REST interface and also serves up the Clerical Review tool as a browser-based app which talks to the REST API. The actions allowed on data via the REST interface are quite simple. Create, read, update and delete operations on a handful of basic data abstractions. These abstractions could be implemented on top of other data repositories, not just the NGLMS and not just graph databases, using a relatively small amount of code, and this would allow the review tool to be used with existing databases and existing linkage unit workflows. This is what allows the review tool to work with the NGLMS and legacy purely relational data. The API hides the nature of the underlying storage paradigm and data organization. Adapting the REST backend to talk to a relational database rather than a graph database only involved tweaks to the implementation of 2 out of the 32 REST endpoints and 0 changes to the front-end browser review tool. It's important to note the review tool as it stands is not for editing records themselves, but the relationships between records. The underlying record data cannot be modified using the review API. Security is not handled by the web application. Security is the responsibility of the back end and not the browser. The browser can only do what is permitted. Even if a malicious actor were to fake requests to the API, they would be forbidden. Such an actor could do no more than what the review tool would already allow them to do. This also applies to any batch tools written on top of the API. As an example, there is no delete record facility in the API, so it's just not possible to delete records from the system using it. The review tool depends on only a small subset of the sophisticated abstractions available in the NGLMS. A project contains meta information about the task at hand, which users are associated with the task, associated work pools and workflows, and any customizable status indicators. Users are needed for authentication and audit. This is essentially a username and password. A user can be a human agent, or, as we'll see later, a batch script or triage tool. Records are the data being reviewed and typically correspond to a row in a database table or view, or a node in a graph. A work pool is a set of IDs of records in certain states, for example, yet to be reviewed or completed. As the review task progresses, the reviewers move records between work pools according to a bespoke workflow. This workflow can be as simple or as complex as desired. The name and meaning of work pools and the allowable transitions between them are specific to each project. Finally, a claim represents the collection of records a reviewer is reviewing and exists as a concurrency mechanism to prevent conflicting things being done to record relationships by different agents at the same time. For a typical task, a linkage manager will create a new project, assign users to it, and design an appropriate workflow. Record IDs are then loaded into the starting work pool. Reviewers grab clusters from review from the to-be-reviewed pool, review them, possibly rearranging the records in them by splitting up and moving them, and then send the result to another pool, for example, the completed work pool. Reviewers repeat this until the to-be-reviewed pool is empty. All of this is affected by the browser calling the appropriate REST endpoints. Because the app is browser-based, there is nothing to install, everyone is always running the same version, and it's self-contained and can easily be deployed on isolated networks. I'm going to now log in to the application running in a browser on my laptop. The review tool has a simple interface consisting of just a login page and a review page, mostly given over to the cluster tables. A small portion at the top controls the work pool under review. Choosing the to-do pool, I can see the workflow options available and the cluster modification actions. Below this section are the 12 records from the dataset in the first slide, which I've reassembled here into one big cluster. Columns can be shown or hidden depending on the task at hand, and the default visibility is controlled by each project's configuration. Each row is a record and can be coloured. Birth records could be made more obvious, or electoral records coloured, as here, to indicate that they are part of a data spine. Clusters can also be coloured or have status icons attached. Inconsistencies, like the presence of more than one birth or death record, can be highlighted. This large cluster has records which differ in gender, so has an icon indicating this. It also has multiple electoral records and another icon to indicate that. As it is split up and these inconsistencies are removed, these icons will disappear. The indicators are implemented as JavaScript and CSS to allow customization on a per project basis or even on a per workpool basis. The byword here is flexibility. Review tasks are not all the same. Goals vary, and so the review tool needs to be as customizable as possible. It's worth noting the review tool need not be used to just review clusters representing the same individual, but also to review other types of relationships between records, such as maternal or sibling relationships between individuals. In such cases, status indicators might be used to differentiate parent and child clusters. I'll split these records into 3 clusters, watch the icons disappear, and move them to the completed pool. And I'm done. I'll pay a quick visit to the completed work pool in a moment to show the 3 newly separated clusters. But before I do, notice that as I was working, the bottom status bar changed colour. This bar shows how long the reviewer has been logged in, and when reviewing, how long the cluster has been under review. The UI can indicate when the reviewer has been reviewing a set of records for an unusually long time, or has been working without a break for too long a period. Here I am in the completed pool. I'll cycle through the clusters and move them back to the to-do pool. Notice the workflow for the completed pool is different to the to-do pool. Once clusters reach here, they're extracted for reporting or analysis or to be sent to clients, or for whatever reason the project was set up in the first place. The REST approach allows custom automated tools to be written in any language to integrate with the workflow. We wrote a triage batch tool, which used the REST interface to sequentially grab clusters from a preliminary pool, analyze them, and move them to other work pools, oversized, slow to extract, singleton clusters, and the normal to-do pool. This created manageable chunks of review work, which could commence immediately, and unusual clusters were siphoned off for separate problem analysis and breaking down into smaller clusters by other specialized and possibly further automated processes. The work pools can be operated on in parallel, allowing normal review to occur concurrently. Moving records between work pools is very much like moving files between folders. Here we can see commands to move all records from the to-do to the completed pool, move the cluster containing person 105 from the completed pool back to the to-do pool, pull all records out of the completed pool, and cluster them according to the parameters of Project 1. These commands mix REST and library commands. The REST API has proven flexible and effective. The NGLMS Clerical Review web application and associated command line tools based on the REST interface form a flexible suite of software for the review and manipulation of linked data, which can work against new and legacy data stores. Its customizable UI and workflow aspects ensure it can effectively service a wide range of review tasks with ease.